Well, hello guys. I am continuing with this series on the different kinematics equations. Remember that the first one we discovered was an equation that we use when we have no final velocity, an equation to get the displacement of an object based on the initial velocity, the time interval, and the acceleration. And our basic conclusion was that you have this formula and we took care of it as equation number 3 because the other two were the two basic equations, the definition of acceleration and the average velocity. So today we need to do the opposite. What if in a given problem we don't know the initial velocity and we don't want to find it out? How do we relate the other four variables, which are displacement, time interval, final velocity, and acceleration? So that's our job today. I hope that we can solve it in a reasonably short time. Let's go to a grid so that we can do this a little shorter. And then remember that the first equation we have is the equation for acceleration. Acceleration is final velocity minus initial velocity over time. Now, the strategy that we are going to follow is exactly the same as before. Because you want to get rid of the initial velocity, you solve the equation for that variable. The problem is that in this case your initial velocity is negative, so you want it on the other side. You want to switch the initial velocity to the left hand side, and so this is a two-step process. First move initial velocity and then move at. So the initial velocity is equal to the final velocity minus at. And so that's your first equation here. And now in the second case you're talking about the average velocity, and this average velocity was given either by displacement over time or initial velocity plus final velocity divided by 2. Now, once again, you want to get rid of the initial velocity, so a simple two-step algebraic solution is that you have twice the displacement over the time interval minus the final velocity, and that's equal to your initial velocity. Therefore, once again, you want to combine two things that are both equal to the initial velocity, and so your equation becomes final velocity minus at is equal to twice the displacement over time minus the final velocity. Now we have to do some algebraic steps. 2 times final velocity minus at, all of it times t is equal to twice the displacement. I think I forgot that over here. Yes, you should have twice the displacement. And now twice final velocity time minus at squared is equal to twice displacement, divide by 2, and what you have is, if you switch sides, that the displacement is equal to the final velocity times the time interval minus 1/2 acceleration time squared. And we have now reached our fourth kinematics equation, and that deserves a little square red rectangle. So this goes into your formula sheet as your next equation. So that's it for today. See you soon.